2.5 number 2. Apply the remainder and factor theorems with emphasis on synthetic division. Algebra 2. In the previous lesson, we looked at long division. Today we'll see how synthetic division is a little easier than long division, but we're limited. What we're limited to is we can only divide by x plus or minus some number. So if I have x squared or 5x or something other than just x I need to divide by, I'm going to still have to use long division. But if I have something like this, where I'm dividing by x plus or minus a single number, then it's perfect for synthetic division and will be a bit faster than long division. Now, if you remember synthetic substitution, we set it up in a similar way. I'm going to put the coefficients of the polynomial along the top here. So I have 1x to the 4th. Now notice I don't have any x cubed. It's going to be important that I put a 0 in for that. Then I have a negative 10x squared, so my coefficient's negative 10. Make sure you get the negative in there. 2x plus 3. Now, if I'm missing a constant term, I would have to put a 0 in that location. Then what I'm dividing by is the 0 that would go with this factor. Well, if x minus 3 was a factor and I set it equal to 0, that would mean that x would have to equal positive 3. So I don't want to put negative 3 over here. I actually want to put positive 3. Now I want to do that process of add, multiply, etc. I start out with addition. 1 plus nothing is just 1. So I bring the 1 below the line. Then I multiply the 1 by the 3, and I put their product above the line. Then I add, sum goes below the line. Then I multiply, product goes above the line. Then add, multiply, add, multiply, and add. Now, I have my last number sectioned off here because that's going to be the remainder. In this case, you can see I have a remainder of 0. So, I can now fill in x's starting with 1 degree less than the original polynomial. Because what we have here, these are the coefficients of the quotient of the answer. Now the reason why I want to start with 1 degree less than x to the 4th is that remember if I divide x into x to the 4th, well that would bring me down to x cubed because x to the 4th divided by x would be x to the 3rd power. So my quotient, my answer, which is already actually written down here, is 1x cubed plus 3x squared minus 1x minus 1. And then if I did have a remainder, I would once again write it as a fraction over what I'm dividing by. In this case, the whole x minus 3. So that's the way I write my answer. And you can see a bit faster than long division. Let's try another one. Now, try not to look ahead at the answer that I have down here. Now that I pointed out, I know it's hard to avoid. Let's see, we have our coefficients. And again, let's make sure we have this set up correctly. We have 3x cubed plus 8x squared plus 5x minus 7. That looks good. I didn't need to fill in any zeros there. And then this x plus 2 would have a 0 of negative 2. So we divide by the negative 2 over here. Now, add, multiply, add, multiply, add, multiply, add. Now see, on this one we do end up having a remainder. I start out with 3x cubed, so now this is going to be x squared. So when I write my answer, 3x squared plus 2x plus 1 plus plus our remainder of negative 9 over x plus 2. And that's it. Let's do one more of these before we look at a couple theorems. Look how this one's set up. We have 2x cubed plus 11x squared, and then I don't have an x term, so I need a 0, and I don't have a constant, so I need another 0. It's important to get those zeros in there. And then x plus 3 would equal 0 when x equals negative 3, so that's what we want to divide by, is the negative 3. Go ahead and try this one. Did you get a remainder of 45? Now to write our answer, remember to put the x's back in. And we can write it as 2x squared plus 5x minus 15 plus our remainder of 45 over what we're dividing by, x plus 3. Maybe you thought you were finished with theorems in geometry. Well, you're wrong. Here's a remainder theorem that we're going to apply in algebra. It says that if a polynomial f of x is divided by x minus k, then the remainder is r, and that equals f of k. What this is saying is that if I have a remainder of, say, 5, well, I get that remainder by plugging k into the initial function. And we'll see how that works in an example in a little bit. You actually saw this connection when we looked at synthetic substitution versus direct substitution. Then we have the factor theorem that says a polynomial f of x has a factor x minus k if and only if f of k equals 0. Meaning if I plug in k into the function, the remainder has to equal 0. Let's apply these theorems in some examples. Here we're asked to factor this function, and we're given that x minus 3 is a factor. Well, if I just was asked to factor this function, before this point in time, I would see that we have 4 terms, and I would try factoring by grouping. But I'd quickly see, if I try factoring by grouping, it wouldn't work out. Let me show you. If we group the first 2 terms together and the second 2 terms together, well, from the first group I can factor out x squared and be left with 2x minus 11. From the second group I could factor out a 3, I'd be left with x plus 12, and then I'm stuck because this factor does not match with this factor. I can't factor it any further from there. So now what I can do instead is narrow down this polynomial by dividing it by one of its factors. Now I know that I can use synthetic division, because this is just x plus or minus a number, to divide it into here, and I should end up with a remainder of 0. If you remember the theorem we just looked at, that says that if it is a factor, that f of x will equal 0. Or in this case, since x minus 3 is a factor, if I plugged in 3 here, f of 3 should equal 0. Now, my goal though is to factor this, so I'm going to use synthetic division, divide 3, which again I got from here, into the 2x cubed minus 11x squared plus 3x plus 36. Be careful to plug in zeros as needed. And let's add, multiply, add, multiply, add, multiply, and you can see I do get a remainder of 0. Now, at this point, if I did not get a remainder of 0, I either did something wrong or x minus 3 is not really a factor. But x minus 3 is a factor, and this confirms it. Now let's see what I'm left with. This would be 2x squared. Remember, it's 1 degree lower than what I started out with x cubed. So 2x squared minus 5x minus 12. Now I'm down to a trinomial. Keep in mind my goal in this problem is to factor it completely. So I want to split that factor, or that polynomial now, into two binomials. And I'm going to use the standard method of factoring of looking at, okay, first times first, these equal 2x squared. 2x and x, my only options. Now to get to negative 12, I have some more options I need to try out. Could be 3 and 4, could be 2 and 6, could be 1 and 12, but I need the right combination that will also get me to minus 5x. Now, I do know that I have to multiply them to get a negative number, so I'm going to have a positive and a negative. Now, I would probably start out with trying 4 and 3. Now, I know I'm not going to put the 4 here because, a little clue, 4 and 2 are both even, meaning I could factor out a 2 if I had a 4 there. But this whole thing is not divisible by 2, so none of my factors should be divisible by 2. So because of that reason, I'm going to try the 4 here, and I'm going to try the 3 here. And then I need to check and see if I get minus 5x. Well, outside times outside is minus 8x. Inside times inside is positive 3x. And I happened on my first shot to get the right answer. 3x minus 8x does equal negative 5x. Now, if it didn't work out, if I ended up getting the opposite of what I wanted, I would just switch the positive sign and the negative sign. If I ended up with a totally different number, then I would try other options like 2 and 6 or 1 and 12. So my answer to this problem, factoring that completely, well, my factors are 2x plus 3 and x minus 4. And my initial factor that they gave me is x minus 3. So if I were to multiply those all out, it would equal the initial polynomial. And that is how we can use a combination of synthetic division and factoring that we have practiced before to factor a polynomial completely. Let's try a multiple choice question. 1, 0 of f of x is x cubed plus x squared, or f of x, which is x cubed plus x squared, minus 16x minus 16 is 4. Well, what does that mean? That means that if I plug 4 in for x into f of x, that it will equal 0. So 4 cubed plus 4 squared minus 16 times 4 minus 16 should equal 0. We want to find which of these other numbers would also equal 0 if I plugged it in. Now, I could start out plugging them into this original function and see which equals 0, or I could narrow down my function a little bit first using synthetic division. So, taking 4, now this is just is 4, so that's saying that x equals 4. So I don't want to plug in negative 4 here, it's just going to be positive 4. 1x cubed, 1x squared, minus 16x, minus 16. And again, let's add, multiply, add, multiply, add, multiply. And I get a remainder of 0 as I should because we were told that 4 is a 0, meaning remainder 0. Now I can put x squared in plus 5x plus 4. And now I'm down to a trinomial that I can factor into two binomials. Or at this point, I could even start testing my numbers, plug them in and see which one will equal 0 when I plug it in. Now if I set it equal to 0 and factor it, I can also find the solution. So this will factor into x and x, positive and positive, and then 1 and 4, because 1 times 4 would equal 4, and 4x plus 1x would equal 5x. Setting x plus 1 equal to 0, I get x equals negative 1, so that would be a 0, which I can see is an option right there. There's another 0 here of x plus 4, so that equals 0. We get x is negative 4, which we can see is not an option on there. So it looks like B is the correct answer. Let's look at one more example. A company's profit C in thousands of dollars can be modeled by this equation. In this equation, X is the number of items produced in thousands. The profit is $14,000 for producing 2,000 items. What other number of items would produce about the same profit? Well, as I look at this problem, I want to keep in mind that C is in thousands of dollars, meaning if I plug this for C into the equation, the thousands is already taken care of. So I'd actually just want to plug in 14 for C. And X is also in thousands. So for X here, for 2,000 items, X would actually just equal 2, representing 2,000. So this means if I plug in 2 for X, it should equal 14. And we can see that using synthetic division. Now, and actually, I'm going to go ahead and plug in the 14 and then subtract it from both sides. So we'll have a minus 14 over here so that it's going to be set equal to 0. And I'm going to find then from there what other values for X would get this to equal 0, because then that minus 14 is already over there. All right, so to narrow down my function a little bit, we can do synthetic division. All right, so synthetic division, we have the 2 into, again, that 2 came from over here, representing 2,000. And our coefficients, negative 5, positive 6, positive 15, and then the minus 14. And again, process, add, multiply, add, multiply, add, multiply, and we do get a remainder of 0, showing us that for 2,000 units, it is going to be a profit of exactly $14,000. Now, let's write what we have left. We have minus 5x squared minus 4x plus 7. And again, I got that from the coefficients here. And now I want to see if I can factor from here. Now, pretty quickly, I'm going to see that actually this is not factorable. I can split up this into minus 5x and x. The only way I can split up 7 is with 7 and 7. It's positive, so I'm going to have to do, well, let's see, since I already have a negative out front here, I'm going to do positive and positive to get to positive 7. And whether I put the 7 here and the 1 here or switch them around, there's no combination that's going to get me to minus 4x here. Because the difference between 7 and 5 is 2, the sum of 7 and 5 is 12, there's no combination that will give me minus 4x. So now I need to think back, well, how else can I find the values of x if I want this to equal 0? Well, if I can't factor and solve, my other option would be the quadratic formula. So, using the quadratic formula, we'd have x equals opposite b plus or minus square root. B squared would be 16 minus 4 times a times c all over 2 times a which would be negative 10. And go ahead and plug that in, see what you get. Did you get about negative 1.65 for one answer and about 0.85 for the other? Well, let's think about what these answers would mean. Remember, we're solving for x here, and x is the number of items produced in thousands. Well, we obviously don't want to produce a negative number. We can't do that. That doesn't make sense. This would represent 0.85 thousand units. Or we could move the decimal place over 3 times. 1, 2, 3, add a 0. So 0.85 thousand would be the same as then 850. So we're looking at about 850 units produced would give us a profit of about $14,000. Now, you might be wondering, how can that be? 2,000 units, we get a profit of $14,000, and 850 units, we get a profit of the same amount? Well, think about how production works. Think about supply and demand. The more units available, the lower the demand, which means usually you can't charge as much and you make less per item. Versus a smaller amount, you can usually charge more per item if the demand is there, and thus make a higher profit. So we can use functions like this for companies to determine, to maximize their profit, how many items they want to produce. And that concludes lesson 2.5, number 2, synthetic division.